My name is Florina Muntenescu, and I'm a developer advocate at Google. And in this talk, I want to tell you about two libraries, the room and the paging library. So we have a lot of content to cover, so I'll go straight in. So whenever I had to work with the databases, for a long time, that was pretty much my face. It was quite complicated because there was so much boilerplate to write. All of that cursor, get in, cursor, get string, all of that object mapping that you had to do by hand. And then whenever I had to change the schema version, I had the feeling that I'm like disarming a bomb because any change that I'm doing might end up with the app exploding in my user's hands. So it was quite difficult to implement migrations. And then it was difficult to test. So in order to check that my queries were indeed correct, I had to run the app, or even implementing a simple test that was checking that the queries are correct was, let's say, not really easy. And not to mention about actually testing the migrations also. And then another thing that's easy to do, and to be honest, I'm also guilty of doing, is doing database operations on the main thread. So that meant that my app ended up skipping frames just because I was doing all sorts of queries or all sorts of work with the database on the main thread. So this is why in the architecture components, we've added room. Its role is to solve all of these problems that I mentioned above. It will do all the object mapping for you. It will do compile time check queries. And in general, it will help you work with the SQLite database. Because under the hood, room is just a wrapper over SQLite. So in today's talk, I want to go over the main components. I want to focus on the stuff that we've added in the latest releases. And while doing this, I'm also going to mention a few tips or a few things that you should have in mind when working with room. So let's start with the components. Let's say that we have a repo class. So this would be a mapping of a GitHub repository. So our repository would have an ID, a name of the repository, and other informations. And we want to have a table in the database that corresponds to this kind of object. So where every line in the database is actually an object of that type. So in order to do this, in room, we use the @entity annotation. More precisely, we annotate our classes with @entity. And then if we want, we can set the table name. If not, room by default will use the class name. And then we need to set a primary key. So here, in our case, it's just the ID, but it can also be a multiple of primary keys. And then we can set the column info. So in the column info, we can define the name of the table. So in this case, we set the name of the ID to be just ID. Whereas for the name of the repository, the room database will just use the name of the field. So in this case, just name. As a pro tip, I recommend that you always use the @column info annotation. And this is because if you want to refactor your data class, so let's say that you want to change the name of a field from, I don't know, maybe ID to a repo ID, if you add the column info annotation, you don't need to change also the column name. To actually change the column name, you have to implement a migration that copies all the data in a temporary table and then does all of that column changes. So it's quite a lot of work just because you want to change a field name. Because chances are you will work with this data class afterwards. And then there's one thing to mention. So you see there that the name is a non-null object. So this means that this corresponds to a non-null column inside our database. So the non-null columns are defined when the table is created. So room will check what's the nullability type in your data definition, and then it will use that to implement the definition of the table. So in this case, it means that if we are trying to insert a null object for the name, we will get an SQL constraint exception, and our application will crash because null objects are not allowed. But then, if the column can be null, then we can easily add also null objects. Similarly, if you're not using Kotlin but Java, room will look for the @non-null annotation. So fields that don't have this annotation automatically will be considered nullable. In this case, the ID can be nullable. So there's one thing that you need to remember, because one change, one question mark, or one non-null or nullable annotation, in the end, can change the schema of your table. So this means that if you're doing just this small change, you'll end up having to implement a migration. So keep that in mind when you're doing these kind of changes. OK, so we've defined our table. Now let's see how we can get the data from it. So to do this, we work with data access objects, or DAOs. More precisely, we will define an interface that's annotated with DAO. And here, we will just define our queries, and then let Room do all the heavy lifting for us. So Room will do all the object mapping that is needed. So like this, we avoid all of that boilerplate that comes with writing manually all these queries. Room also supports inheritance. So more precisely, we can define a base DAO that knows how to insert, update, and delete data in a table. But then queries that are specific to each table will have to be defined in each table's DAO. So for example, to actually get the list of repos, we would implement the query inside the repo DAO. So this is because otherwise, Room doesn't know which table are you talking about. You can't really make a table generic. OK. Also, when you're returning something from an entity, when you're returning something from a table, it can either be an entity, or it can be a subset of the columns that you're interested in. So for example, here, we can just get the name of the repositories. But also, we can get a subset of the fields. So for example, when we want to just display some stuff to the UI, we can request a subset of the list of fields that we need. Even more, in the latest releases, we've also added support for Guava optionals and Java util optionals. So this means that if the element does not exist, so if the query would return empty results, your optional will just return either absent or empty, depending on which optional you're using. OK, so now we know what the entities are, and we know how to query them, but we didn't actually connect everything together. We haven't defined our database. And this is done with the @database annotation. So more precisely, we would define an abstract class that extends from the Room database. We would annotate it with that database. We would add the list of entities, and then the version number for the database. Also, what's important here to remember is that only the entities that you add here in this list will be created by Room. So if you're defining multiple tables, but you forget to add them here, don't be surprised if your database is missing those tables. Also, here you would define the DAOs that the database can work with. Then when you're actually constructing the database, make sure that it's a singleton. So for example, if you're working with Dagger, probably you would annotate it with an @singleton annotation. And this is because, in general, with SQLite, if you have multiple connections of the database open in the same time, you might end up with synchronization issues, with threading issues. So just try to make it a singleton. Then in terms of queries, Room provides 5 different options: insert, update, delete, query, and raw query. So we'll start looking at insert, update, and delete, because these are pretty much the same under the hood. OK, so in our DAO interface, we would define insert, update, and delete. Let's see what Room does for us. So Room creates the implementation of this interface. And here, it will work with an instance of the Room database. And this Room database is actually the one that you defined in your application. And then, in the implementation of our method, it will do all the heavy lifting for us. So it will start the transaction, then insert the data, then set the transaction as successful, and then add transaction. So what's important to remember here, or to notice here, is that Room handles the transaction for us. So it makes sure that the operations that we're doing here are atomic. So this means that if you want to insert a list of repositories, Room will make sure that this insertion of lists is also atomic in one transaction. But what if we want to do more complicated things? What if we want to both add and remove a repository from our database also in one transaction? To do this, Room adds the @transaction annotation. So it gives you the flexibility of implementing transaction yourself and then define what should happen in that transaction. Under the hood, Room will just actually wrap whatever code you define in that begin, set transaction successful, and transaction code. Okay, let's look at the threading model. So insert, update, and delete are synchronous. And actually, query can also be synchronous. So this means that they will be run from whatever thread you're triggering them from. But if that thread is the UI one, well, you will get an illegal state exception because saying that Room contacts the database on the main thread. So this means that you automatically are forced to avoid these kind of threading issues and in the end providing a better user experience for your users. Let's look a bit more at query. So let's say that we're defining a query when we want to get a repository based on the name. So we can do this synchronous just by getting the repository by name. So this means that here you'll need to take care of the threading. But we can also do this asynchronously by either returning maybe or single, but also using observable queries, either by using live data or flowable. So I talked about live data yesterday. So live data is just a data holder that keeps a value to be observed in the scope of a life cycle. So it's not a very complicated concept, I would say. But let's see what's going on here with maybe and single and what's the difference between them. So let's say that we want to get the repository with ID, well, with a certain name. So when we get, let's say, the repo by ID 3, what we get is 3 and Android KTX. So, and then that's it. So both maybe and single will just complete in this case. But then when we try to get the repo with ID 26, we don't have that kind of repo. So this is what will happen. In the case of single, we will get empty result set exception because there is no such repo that Room can return. And then in the case of maybe, it will just complete. So let's see what happens with live data and flowable. So if we try to get the repo by ID 3, we will just get 3 and Android KTX. But then, if we want to change the name of the repository, so for example, from Android KTX, we want to go to core KTX, then automatically both the live data and the flowable will emit with this new value, so 3 and core KTX. Things are different when we're trying to get the repo by an ID that doesn't exist. So for example, when we're trying to get the live data with ID 26. This doesn't exist, so live data will just return null. But in the case of the flowable, because flowables don't support null, nothing will happen. So if you want indeed to be notified of the data missing, and then when you're adding the data, so the data for that specific value, it's going to be added automatically. But if you want to actually handle this, so handle the fact that the data is missing, you can either work with optionals. So for example, returning an optional of the repo, and then that optional will be empty or absent, depending on which optional you're using. Or you can work with a list of repositories. So then even if you're trying to get the data for one value, that list will be empty, and that will tell you that you don't have any items that match your query. Okay, there's one thing that you need to remember. So let's say that we want to get the repo by ID 3. So it will be 3 and Android KTX. But then we're adding another one. We're adding another item for ID 26, so nothing to do with our ID 3. Well, both for live data and for flowable, we will get another notification. Because under the hood, Room just uses some observers that SQLite provides for the table. So it doesn't really know what happened, what changed. So what Room does is just trigger again the same query that we defined. So whenever the data in the table changed. So this is why we would get another notification with the same result. So I would say I would call this as a false positive, because in the end nothing changed. So in order to fix this or to work around this, we can create a, let's say, repo by name distinct method in our DAO, and this is how it will look like. So if you're using flowable, I think the easiest solution is to use the distinct until change operator, and then let RxJava handle all the magic for you of just exposing unique elements or distinct elements. But then if you're using live data, it's not that complicated to also overcome this. So I would create a method that's called, let's say, distinct. And then here, I would just be working with a mediator live data, where I'm adding as a source the query in the DAO. So then I keep in memory the last object that was emitted. Initially was null. And then whenever something was emitted, so whenever onChange is triggered, I'm just comparing if that new object is the same or not with the object that I previously emitted. And that's it. OK, so another difference between, well, synchronous and asynchronous or observable queries is the threading model. So this means that both live data and flowable run on the background thread. So the query will be done on the background thread. But the difference comes in where the result is returned, because live data will automatically return the result on the main thread, whereas the flowable, well, it will return the result on whatever scheduler you're setting. The last query that we've added actually quite recently is the raw query. So this means that if you want to dynamically define your queries, you can work with a support SQLite query. So this is something that just comes from SQLite. And then you can annotate a method with the raw query. And then under the hood, Room will take care of doing the object mapping for you. So it will take care of creating everything that's needed for the query and return the data that you're interested in. You can also return observable queries, but on top of the raw query, you have to add what are the observed entities that you're interested in. So in my case, it's just the repo class. But if the query that I'm triggering is something that connects multiple tables, make sure that you're adding here all the tables that you need. OK, database relations. So let's say that we have a repo class and the corresponding table. And we also have a commit class with the corresponding table that keeps all the commits for all the repos. So this means that there's a connection between the primary key in the repo and then the field repo from the list of commits. So in order to enforce this connection, we would use foreign keys. So here we would say, what's the connection between the repo class and the commit class, and say that this is based on the ID, respectively repo ID columns. And then Room also allows setting what should happen on delete or on update. So all of this, all the foreign keys concepts are not foreign to us because they just come from the SQLite database. Room just exposes APIs to work with them. But let's say that we want to get a repository with the list of commits. So in order to do this, you would usually need to first get all the repositories, and then based on all of those repositories, get all the commits for them. So you would need to trigger 2 queries. So we know that this is not really, or let's say, handy, so we can help you. We can help you with the @relation annotation. So more precisely, here I'm defining I'm embedding the repo. So this means that I'm telling Room that I want all the fields from the repository, from that table. And then I'm adding a list of commits. And by doing this, I'm telling Room that I'm connecting the repo ID field from the repo with the ID field from the commit. So automatically, Room will trigger both of these queries that we defined before. And then in the DAO, all we need to do is tell Room that we want a list of repo with commits. And then that's all. In order to test this, this is what we need to do. So we would work with the database. We would work with the DAO. We would need to implement an Android JUnit test for this also. So in the addBefore method, we will need to define an in-memory database. So the advantage of an in-memory database is that it doesn't keep the data after the process died. So as soon as the test has finished, everything we've inserted or every work that we did with the database will be removed. And then to actually implement a test, we would insert some data. And then when we're working with live data, we would need to get the list of repositories, let's say, by name. And one thing to remember is that you need to add the instant task executor rule. So because by default, live data will work on the background thread, we want to make this a synchronous operation. So this instant task executor rule will replace the executor that architecture component is using under the hood with a synchronous one. So this means that afterwards you can easily get the value that was returned or that was emitted by the live data and check that indeed that is the requested one. Using the RxJava flowable, things are pretty similar. So you would still need to use the instant task executor and then just get the test value and then get the test and then assert that the value is the one that you expect. But then if you want to implement espresso test that under the hood also tests code that uses room, that uses asynchronous operations, then you would use the counting task executor rule. I won't go over in detail of how to use this, but check out the samples that we have because we also have examples of how to use this counting task executor rule. I also wanted to talk to you today about migrations, but this is quite of a bigger topic, and because I also want to tell you about paging, I'm just going to point you to two articles that I wrote, one about understanding migrations in Room and one about testing migrations. I don't think they're easy to do. We also provide handy tests. I don't think it's hard to do, because we're also providing some very handy test rules to test the migrations. So we talked about holding or keeping the data in the database. But the thing is that a lot of times our apps are working with large sets of data, but in the end, they only need to display small amounts of data at one time. And if we're not careful, we might end up requesting data that's not needed. And we know that it's actually quite difficult to present fresh data to the user, especially if that data ends up changing or being changed by a third party. And then it's also hard to keep small amounts of data in memory, so to avoid getting all that data from database, for example. So in order to help with this, we've created the paging library. So I want to go today over the main components of the paging library. And the example that we will use is also a list of repositories. So more precisely, we are just querying the GitHub API and getting all the repositories that have a certain name. So let's look a little bit at the architecture of our application. So we would have a repository that would work with the network and with the database. And then usually in our apps, you would expose live data of a list of repositories. Then we would have a view model that works with that live data of a list of repo. And then a UI that is in charge of displaying that list. So it will have a recycler view adapter and an actual recycler view. Okay, so one of the main components of paging is the page list. So page list is actually nothing more than a collection. It actually extends a list. But what it does is load data in pages asynchronously. So this means that in our application, instead of working with a live data of a list of repos, we would work with a live data of a paged list. And then let the paging library do the paging, the requesting of the data in chunks for us. But then the page list will be consumed by the page list adapter. So by default, when you're using the recycler view, chances are that you're either using recycler view adapter, or if you've already migrated to the 27.1 version of the support library, you might be using a list adapter. So the page list adapter is nothing more than a wrapper over list adapter. So it extends list adapter. So if you haven't worked with list adapter, I'm going to tell you what's with that repo comparator. So based on the repo comparator, we're telling the diffutil, so we're telling the recycler view how to compare two different items. We're telling based on what two items can be considered the same, or can be considered that the contents of these items are the same. So this means that we would work with a page list adapter, and then in our UI, we would just submit the list. So here we are observing the live data of a page list, and whenever on change is triggered, we are setting that list to the adapter. So then in our UI, we're just changing the recycler view adapter to a page list adapter, working with a page list. Another element is the data source. So where are we actually getting the data? Its role, the role of this class is just to load snapshots of data into a page list. I'm not going to go right now in detail about this, but I will a bit later. We will also need to define a data source factory, where we define how should the data source be created. So in our case, we just need to implement the create method and create the data source that we need. Okay, so looking at our diagram again, we see that we have a live data of a page list, we have a page list adapter, and also a data source factory that gets the data from a data source. The data source can either be the database or the network. But what we haven't done is actually construct that live data of a page list. And this is done with the live page list builder. So more precisely here, you would pass as a parameter in the constructor the data source factory and the page size, or more detailed information of how you want to configure your page list. So this is what you can configure. You can set the size of the page. What we recommend here is to make it longer than one screen, because otherwise, if the page size is smaller than a screen, then you can end up with flickering issues. Then you can set the initial load size hint. So this is the amount of data that should be loaded by the paging library the first time. By default, we're setting this to be 3 times of the page size. Next, we can set the prefetch distance. So what's the distance from the end of the list when the paging library should start requesting for more items? And then, whether we should enable placeholders or not. By default, this value is true. So this is what it actually means. Whenever we're getting the list of data, the paging library knows when we're triggering the request of the next list. So while that next page is being paged, the paging library just returns null for those items. So this means that right now you can add placeholder items for your list. If you don't want to work with live data and you prefer working with RxJava, you can use the Rx page list builder. So this is constructed similarly with the live page list builder by just putting the data source factory and the config. But you can either build an observable or a flowable based on a backpressure strategy. The Rx page list builder gives you a bit more flexibility, because also you can set the default fetch scheduler. You can set the fetch scheduler, and by default, the architecture components will use the IO thread executor. So it will use actually the same type of executor that is using for live data. And the notify scheduler, which by default is the same mechanism as for live data, the main thread executor. Okay, now we kept on adding a few components, but we didn't go into detail into the in the data source. So the data source can either be the database, it can be network, or it can be the database and the network. So let's go over all of these 3 cases. So the first one, when the data source is our database. So the paging library has a close integration with Room. So this means that actually in our DAO, we can also return a data source factory. So for example, here we're saying that we want to return all the repos from the database that have a certain name. And we can let Room do all the implementation of the data source and the data source factory for us. But if the data source is the network, we have 2 different cases. One, when the data is requested based on a key. So in our remote data, we would define a remote data source that extends item keyed data source. So an example for this would be when we want to request all the commits that happen after a certain date. That date would be the key that we would work with. So more precisely, in our item key, the data source, we would define how the initial load should be triggered based on initial load parameters, and then the result should be passed to the load initial callback. And then, once the paging library has finished displaying all the data that we initially requested, it will tell us, or it will tell the data source to get the next bunch of data. So it will trigger the load after method. So more precisely here, we would get again from the load parameters the key that we're interested in. So here it would be that date that I was mentioning before. And then once the data is loaded, we will trigger the load callback, or we will put the result in the load callback. Also, if we're supporting also swipe up, we can define what should happen when we want to load before a certain item. But paging library also supports requesting data based on a page. So to do this, you would implement a page-keyed data source. In our case, to request a list of repositories based on name, we would work with a GitHub API that exposes a page-based API. So we would tell what is the query, what's the page number, and what's the page size that we want to load. So this means that in the initial load, we would just request the page 1 with our query. And then afterwards, we would request the following pages as we need them. And then we can also support the load before in a similar way as the item keyed data source. Okay, so this was let's see a bigger picture of what's going on under the hood with the paging library. So the first step is to build the live page list builder. When we're building the page live list builder, then it automatically triggers the create method from the data source factory, which then creates the data source. Then, based on that data source, the live page list builder will build a page list. So this means that the page list will have a reference and will work directly with that data source. And then the page list will trigger the load initial for that data source. It will get the data, and then the live data will be populated with the correct value. And then that will be omitted afterwards towards the adapter, and then the list will be displayed. But then, once we're scrolling and we're getting to the end of the list, here's what happens. Automatically, the page list is requesting the data from the data source by calling load after. And then the data source will know how to load that data and then automatically send it to the page list. Okay, let's go to a more complicated case. So what happens when we want to work with a database that is backed by network data? So in the end, what we want to do is we want to show data all coming from the database. But whenever we don't have any more data in the database, we want to trigger a request to the network to add more data in the database. So the database is, in the end, the source of truth of data for the UI. So this is what we need to do. So we would still work with Room for returning a data source factory. But there's one new component that we need to add. And this is the boundary callback. So to the boundary callback will be the one that informs us when either there was nothing in the database or we reached the end of the list in the database. So in the boundary callback, we would define the query, we would define the GitHub API service, and the database. And then when 0 items were loaded, so let's say the first time when we're launching the application, the paging library will try to get the data from Room. There's nothing in the database. So on 0 items loaded is triggered. And this is the time when we're requesting data from the backend. Similarly, once we reached the end of the data in the database, we can tell or we can define how we should request more data from our backend. Then this boundary callback needs to be set to the live page list builder so it can be used. Okay, let's see again the big picture and see what's happening here. So first, live page list builder is calling build. It's calling create on the data source factory. And then the boundary callback is created when we're setting the boundary callback. Based on these two elements, the page list is being created. And now two things are happening in the same time. So load initial is called to the data source, but also the page list is being created. So at this time, the page list is empty. So this page, the data source is now triggering a request to the boundary callback because there was nothing in the database. So on 0 item loaded is called on the boundary callback, which in the end requests the data to the network. But then meanwhile, our live data is emitting the first page list, so the empty one, because right now we still don't have anything. Our network request is on progress. With our data source, now, meanwhile, the network gets the data, and we're saving that data in the UI. In the page list adapter, we're now displaying the page list, the empty page list. But because the data source was modified, because we've added elements in it by inserting the response from the network, then the data source needs to be invalidated. So this means that a new data source is created by triggering again the data source factory on create. But this is all done under the hood for you. So then the data source is recreated, a new page list is created, this time with data, and is then sent to the adapter. And then once we have the data, we're displaying the data in the UI. And then once we're scrolling the list, the first thing that the page list will do is get the data from the database. And you can also set different sizes between the list of, or the page size that you're requesting from the network and the page size that you're working in the UI. So for example, let's say you would set that you want to get 100 elements from the network, but only 50 to be displayed on the UI. So this means that initially, the paging library will request 50 items from the database. It will display those. Once you're scrolling, it will request 50 more. It will display those. But then, once we reach the end of the list, it won't have any more data. So this means that it will tell the data source to get more. It will trigger the load after method that will call data source on item at end loaded, that will request more data from the network, and then it will save the data. So overall, this is how paging works. We're trying to simplify things, to make things easier for you in terms of both saving the data with the help of Room, but also in displaying that data to the UI with the help of the paging library. So that's it for now. We also have a workshop on architecture components, just covering lifecycle live data, view models, and Room a bit later after lunch. So join that one if you want to learn more of how to practically work with architecture components. I think we might still have time for questions, but I prefer one-on-one questions, so I'll be here waiting for your questions. Thank you.